These are the doodle notes for Chapter 3, Section 2 of the periodic table. And the first thing we're going to do is, if you were to imagine your paper in thirds, my first thing is going to go into this first third of the page. So the first thing we're going to talk about is a square in the periodic table. So we're going to zoom into the periodic table and we're going to look closely at a particular square. So let's look at nitrogen. If you were to look at a square of nitrogen, you would see the symbol, the name, and then you would see the atomic number and the atomic mass. So each component has specific reason for being on the periodic table. The number 7 is the atomic number. And this is the number of protons. Then we have the atomic mass. And this is the protons and the neutrons. So this number is going to be a bigger number because it not only includes the protons, but it includes the protons and the neutrons. This is the symbol. And this is the name. Now, not always are you going to see that the periodic table has the atomic number at the top and the atomic mass underneath. It all depends on what publisher, how they want to arrange the periodic table. Sometimes you'll see it this way, where you still have the atomic number, but in this case the atomic number is down below and the atomic mass is up top. Always remember that the protons equals the electrons. So if you know the protons, you also know the electrons. So the positives equal the negatives. So if we have 7 protons, we have 7 electrons. Okay, now we're going to go to the middle of our page and we're going to look specifically at the table and how it's organized. So if we were to draw a picture of the periodic table, an outline of it, we would notice that there are 7 rows. Row 1, row 2, 3, 4, 5, 6, and 7. And these rows are called periods. And there are 7 periods in the periodic table. Now, a column is called a group or a family. group, G-R-O-U-P, or a family. And everything in a family has similar properties. So elements in a group or family have similar properties. We also want to make a little note on the side here just to remind ourselves of the father of the periodic table, and that's Mendeleev. Okay? On the bottom third of our page, we're going to talk about valence electrons. And we're going to remind ourselves how we can use the periodic table to identify how many valence electrons each element has. And remember, the electrons are the valence electrons are the electrons in the outermost shell, and they're responsible for bonding with other elements. So if again we were to draw an outline of the periodic table, we would use the columns to identify how many valence electrons. Now remember, 8 is the most stable, so the most you can have is 8 valence electrons. So we're going to skip the transition metals because I'm not going to ask you to tell me the valence electrons of the transition metals. If you wanted to, you could do Bohr atomic models and see how many electrons are in the outermost levels. So we've got 1 in the first column. These have 1 valence electrons. The second family, group 2, has 2 valence electrons. Skip over to group 13, has 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7. And then the noble gases have 8 valence electrons, and they're the most stable. Now we're going to turn our page over, and we're going to create some Bohr atomic models using the information from the periodic table. So let's look at nitrogen. That's a square of nitrogen, or the square for nitrogen. And if we were to look at the periodic table for nitrogen, you would find it located right here. It's in group 15. And it's in the second period, second row. So because it's in group 15, we know it has 5 valence electrons. So let's go ahead and make our Bohr model. We've got our nucleus. And in our nucleus, we're going to put our number of protons. So there's 7 protons. And we're going to put our neutrons. And if we take the 7 protons away from the atomic mass, because the atomic mass is the protons and the neutrons. So if we take out the 7 protons, that leaves us with 7 neutrons. So there are 7 neutrons. And then when we put, because it's in period 2, we know that there are 2 orbitals around nitrogen, around the element. And we know that there are 5 valence electrons because it's in the 15th group. So there's going to be 5 of these in the outermost shell. Now all we have to do is fill in the first orbital, and the first orbital we know can hold maximum 2. So that makes 1, 2, 3, 4, 5, 6, 7. And our protons equals our electrons, so there's 7 and 7. Now if we were to make an electron dot diagram, of nitrogen, then we would use the symbol for nitrogen, and then we would put however many valence electrons, they would be represented with dots. 2, 3, 4, 5. So that's the electron dot diagram of nitrogen. Notice that's not how many total electrons nitrogen has. It has 7 total, but this is the outermost electron. Those are your valence electrons. So let's do this again. Using sodium. Sodium has an atomic number of 11, an atomic mass of 13. If you were looking at a periodic table, you would find sodium right here. It's in the first group, and it's in the 3rd period. So if we were to make our Bohr model, we would have our nucleus. It has 11 protons. So the atomic mass, our number of protons, is going to be 11. Sorry if there's a little glitch in the audio here. I had to finish this a day after, and I don't know what I said the day before. So there's 11 protons, okay, 11p. We subtract 11 from 23 to find out the neutrons, because we're subtracting out the number of protons from the atomic weight or the atomic mass, which is the protons and the neutrons. So in order to find the neutrons, we subtract out the protons, and that gives us 12. So there are 12 neutrons. Now, because sodium is in the 3rd row, it's in the 3rd period, that means we're going to have 3 orbitals. It's in the 1st column, or the 1st group, which means it has 1 valence electron. Now we're not done. There's actually, the protons equal the electrons. So if there's 11 protons, that means there's a total of 11 electrons. So we're going to put 2 in the 1st orbital, 8 in the next orbital. That makes 10, and the 11th one is the valence electron, the one in the outermost shell. Okay? So then the last one that we're going to do at the very bottom, the one thing I forgot is to do your electron dot diagram for sodium. So we're going to do Na is the symbol, and the dot is the 1 valence electron. So that's how to make the electron dot diagram for sodium. The last one we'll do is carbon. Okay, if you look at a square of carbon, it has an atomic number of 6, an atomic mass of 12. On the periodic table, carbon is right here, which is in period 2, so it's in row 2, and it's in group 14, and that means it has 4 valence electrons. So when we draw our atomic model, our Bohr model, we're going to have our nucleus. Inside of our nucleus, we're going to put our protons. There are 6 protons. We're going to subtract that 6 protons from the total of 12 to get 6 neutrons. So there are 6 neutrons. It is in the second row, which means our atom is going to, or our second period, which means our atom is going to have 2 orbitals. It is in the 4th column, which means it is going to have 4 valence, or 14th column, which means it's going to have 4 valence electrons. Its total electrons are 6, so you have 2 electrons in the first orbital and 4 in the outer orbital, totaling 6. And then we have to do our electron dot diagram. So we're going to use the symbol for carbon. And then the number of valence electrons here is going to be how many dots we put around carbon. 1, 2, 3, 4. And that's all for those doodle notes.